Welcome students, welcome to TKG classes. So in previous class we are discussing about the basic thing of refraction of light. That is, what is refraction, a laws of refraction, a refractive index, lateral displacement, etc. In this class we will discussing about the topic, that is definition of lens and its classification, rules for image formation by convex lens and image formation by convex lens. Then we have to study image formation by concave lens and its rules for formation of image. Then we have to study power of a lens. So let's begin. So at first we have to learn the definition of lens. So what is lens? This lens is a transparent refracting medium which is bounded by one curved surface. One point is important here, that is, one surface must be curved, and the transparent, that means light can easily travel. Refracting, that means light bend. So lens, that means is a medium where light can easily travel, light can bend, and one surface must be curved. Clear? So lens are categorized mainly in two categories. One is convex lens and another one is concave lens. So at first we have to learn convex lens. So what is convex lens? Convex lens, that means which is thick at the middle portion and thin at the ending portion, at the corner portion. These types of lens is called convex lens, and this lens has a nature, that is the converging nature. And what is converging nature? Just see the figure. When a rays of light parallel to the principal and after passing through the lens, they will meet at a particular point, they converge at a particular point. So when a rays of light parallel to the principal axis and they meet at a particular point, that is they are converging, this nature is called the converging nature of light, which is seen by convex lens. Now we have to learn the types of convex lens. Convex lens are categorized also three categories. One is biconvex, that means both the surface is convex. Another one is plano-convex, that is one surface is plane, another surface is convex, and the final one, that is concavo-convex, that is one surface is concave and another surface is convex. Now what is concave lens? The concave lens means there is thick for the corner and thin at the middle portion. These types of lens as a nature is called the diverging nature. And what is diverging nature? That is when a rays of light parallel to the principal axis, after passing through the lens, it will diverge, never meet at a particular point. It will deviate it, and this nature is called the diverging nature, and which is seen by concave lens. Similarly, like convex lens, concave lens also categorized in three categories. Biconcave, that is the both the surface is concave. Plano-concave, that is one surface is plane, another surface is concave. And one is convexo-concave, that is one surface is convex and another surface is concave. So this is all about basic thing, that is lens. Now we have to study the rules for formation of images by convex lens, and there are three rules. Rule number one: when a ray of light parallel to the principal axis, after passing through a convex lens, it will pass through the focus on the other side of the lens. Just see the figure. The rays of light parallel to the principal axis, after passing through the lens, it will converge, it will meet at a particular point, and this point is called the focus point, and this is the second focus point or principal focus point. That is the rule number one. Now rule number two, and the rule number two is a ray of light passing through the focus will emerge parallel to the principal axis after refraction. That is just opposite to rule number one. When a ray of light parallel to the focus, when a ray of light incident through the focus, it will be parallel. Okay. Now rule number three, there is a ray of light passing through the optical center will pass without any deviation. So ray of light which is passing through the optical center, there is no deviation, it will passing through this optical center also. So there are three rules for formation of images by convex lens, and we know that for image formation the minimum two rays are required. Now we have to study the images, formation of images by convex lens. First case, that is when object placed at infinity. When object placed at infinity, rays of light from infinity, that is parallel, and the parallel rays of light which is parallel to the principal axis, after passing through the lens, it will meet where? That is meet at a particular point, and this point is called the focus point, that is the principal focus point. So here image formed at focus, that is f2, and this image is really meet, the rays of light are really meted here. So this image is real image and inverted. And what is the size of this image? It looks like a point object. Now case number 2, that is when object beyond 2f2 or c1. Just see the figure here, AB is the object which is placed beyond 2f2, and formation of image will require two rays, one ray which is parallel to the principal axis. So after passing through the lens, it will pass through the focus point f2, and another ray which is passing through the optical center. So there is no deviation, it will remains unchanged, it will pass through the optical center. So these two rays meets at point a dash. So here a dash b dash is the image for the object AB, and this image is formed at the position, just see, between f2 and 2f2. And what is the nature? Real rays are meet, that is real, inverted, and the size is diminished, that is a dash b dash is smaller than AB. So this is case number 2. Now case 3, that is when object placed at 2f1 or at c1. Just see here, AB is the object which is placed at 2f1, and two rays, one ray which is parallel to the principal axis is passing to the focus point f2, and another ray which is passing to the optical center, there is no deviation, and these two rays meet at point a dash. So here a dash b dash is the image for the object AB, and this image exactly same size as object, and the position of this image is 2f2. And what is the nature? Here nature is also same, real rays are meted, that is real, and AB is the upright and A dash B dash is the downward, so this is inverted. So nature is real inverted and the size is same as that of the object. Now case number 4 that is when object between f1 and 2f1. Condition same, one ray which is parallel to the principal axis is passing through the focus, and another ray which is passing through the optical center, it will pass remains unchanged, that is there is no deviation, and these two rays meted at point a dash. Here a dash b dash is the image for AB, and just see a dash b dash is placed position, that is beyond 2f2. Nature same, real inverted, and just see the figure here, E dash B dash, this size, that is larger than the object, so size is enlarged. Clear? So this is about image formation for object when placed at when placed between f1 and 2f1. Now case number 4, that is when object is placed at f1, where the image will be formed. So when object placed at f1, condition same, one ray which is parallel to the principal axis, it will be passing through the focus point, and another ray which is passing through the optical center, there is no deviation. So just see the figure here, two rays, one ray which is parallel to the principal axis and another ray which is passing through the optical center. These two rays both are parallel to each other. So where the image will be formed? The parallel rays are formed image at infinity. So here what is the position of image? The position of image, that is at infinity. Real rays are meted, that is real and inverted. And what is the size? Image formed at infinity, that means the size of the image, that is highly enlarged with respect to object. So this is the condition when the image formed at infinity and the size of the image that is highly enlarged. So at what condition image formed at infinity by convex lens? That is when object placed at f1 the image formed at infinity. Clear? This is an important part. Now last part, that is 6 condition. This is also an important part, and the condition is when object is placed between f1 and the optical center O, where the image will be formed. Condition same, one ray which is parallel to the principal axis passing through the optical center, passing through the focus point, another ray which is passing through the optical center, there is no deviation. And just see the figure here, two rays are not parallel, they are looks like diverging, they never meet that side. So where the image will be formed? If we draw these two rays in the backward direction, just see the figure, they meet at point A dash. So here A dash B dash is the image for the object AB, and this image is the same side of the object. This is the special condition, and this image nature is also different. That is, here real image never meets. So this image nature is virtual, and AB upright, A dash B dash also upright, so that is called erect, and the size that is enlarged. Clear? So in convex lens image formation, both the 5 cases are nature that is real and inverted, and this case, the final one, the nature is virtual and erect. So there are 6 cases for image formation by convex lens. Students, observe one important thing here. Like object moves towards the lens gradually, the image position also goes away from the lens. That is, when object at infinity, the image form at focus, and the nature is that is real inverted, and the size that is point object. After that, when object plays beyond 2f1, that in that condition the image formed between f2 and 2f2, and the nature real inverted and the smaller than the object. Then third condition, that is when object placed at 2f1, then the image formed at 2f2, and there is the same size, same as object, that is the object height and image height is same, that is also real and inverted. Then when object placed between 2f1 and f1, then image formed beyond 2f2. Okay, that means when object moving away, moving closer to the lens, then the image going away from the lens. And then when object placed at focus, then the image formed at infinity. That means the size of the image that is enlarged. And there is also an important part, last one, that is when object placed between focus and the optical center, and in that condition the image is formed at the same site as the object. And here in this particular case, the image nature that is virtual and erect, and the size that is enlarged. So this is all about the image formation by convex lens. Now we have to study the image formation, rules for image formation by concave lens. And rule number 1, that is a ray of light which is parallel to the principal axis, and all of you know that for a concave lens the rays are diverge. So just see the figure here, rays are diverging, but if we draw the diverging rays backward, then it will meet at a point. This point is called focal point, that is f2 or second focus point or principal focus point. Sometimes question are given, what is focus point, principal focus point? So what will be the answer? The answer will be, the rays of light which comes parallel to the principal axis, and these rays of light diverge, and these diverging rays on being produced backward and it meet at a particular point on the principal axis. This point is called the focus point. So this is rule number 1. Now rule number 2, and rule number 2, that is exactly opposite to rule number 1. There is a ray of light which appears to meet the focus. This will be diverge parallel to the principal axis. Next, rule number 3, and the rule number 3 is when a ray of light passing through the optical center, this ray of light will be undeviated. That means there will be no deviation. The rays of light will be passing through same path. So this is all about the rules for formation of image. Now we have to study image formation by a concave lens. Okay, so the first condition, that is when object placed at infinity. Now when object placed at infinity, all of you know from infinity the rays of light that is parallel to the principal axis. So here the rays of light which is parallel to the principal axis will diverge. So these two diverging rays never meet. But if we draw it in backward direction, then it will meet at a particular point, and this point is called the focus point. So here image formed at the focus point. So here real image not meted here. So this nature, that is virtual, and that is also erect, and the size, that means it looks like a point object. Clear? Now there is another condition, there is second condition, and the second condition is when object placed between any point, that means between infinity and the optical center. Okay, so just see the figure here. Object AB is placed between two F1 and F1. So a ray which is parallel to the principal axis will diverge, and another ray will passing through the optical center, this one undeviated. So these two rays are really not meted. So these diverging rays, if we draw in backward these diverging rays meet at a point A. So here AB is the image for the object A dash B dash, this one will be. So what is the position? The image position, that is F1 and optical center. Here also image nature, that is virtual and erect, and the size, that is diminished. So image size is smaller than the object size. In every case here the image size will be diminished. Okay, now we have to study some rules. That is, at first we have to study lens formula. So what is lens formula? In previous class we discussed for in case of mirror formula. Lens formula, that means the relation among object distance, image distance and focal length. All of you know what is object distance, image distance and focal length. Okay, so and the relation is 1 by image distance minus 1 by object distance is equal to 1 by focal length. So if we represent image distance by symbol V, object distance by U and the focal length by F, then the formula will be 1 by V minus 1 by U is equal to 1 by F. Now there is another definition, that is linear magnification, and the definition of linear magnification, that is, it is the ratio of height of the image to the height of the object. And here height of the image is represented by h dash and height of the object is represented by h. Then this formula can be written as m equal to h dash by h. Here m represent linear magnification. Now there is another formula, that is m equal to v by u, that is image distance by object distance. So combining them, then formula will be m equal to v by u is equal to h dash by h. Now we have to study power of a lens, that is the definition of power, and the definition of power, that is the reciprocal of focal length is called power. That means a lens producing more converging or more diverging is said to more power. Then what will be the formula? the power of a lens is related to focal length by the equation that is P equal to 1 by F. Here F is measured in unit meter. But if in centimeter, then the formula of power and focal length will be F equal to 100 by F. Sorry, P equal to 100 by F. P is the power and F is the focal length. And here F is measured in centimeter. So what will be the unit of power? That is 1 by focal length, that means 1 by meter. It is called a diopter. SI unit of power, that is diopter. And here we use for convex lens the power value is positive, and for concave lens the power value is negative. Now you see there is some formula related to lens formula and power of lens. Solve it and you check your understanding level. At first you have to check the sign convention. All of you know the sign convention. When and the distance opposite to the direction of rays, that is taken as negative. The distance along the direction of rays, that is taken as positive. The object or image upward to the principal axis, then it will be positive. Object or image downward to the principal axis, it will be taken as negative. And you have to use lens formula and linear magnification formula. So solve it. So this is all about chapter light. So in this class what we learned? At first we study the spherical lens and its classification. Then we will study that spherical lens are two types, convex and concave. Convex lens makes two types of images. One that is real and inverted, and in this case the image may be enlarged, may be diminished, may be same. All case will be happened. And second condition, that is upright or erect and virtual image, and this condition is happened when object is placed between focus and the optical center. And here the image, the size of image, that is enlarged and same side as that of the object. This is a particular case. And then we study that for in case of concave lens, always we observe that the image size, that is diminished. After that we study lens formula, linear magnification, power of lens, etc. So this is all about today class. If there any problem, any confusion, just post in the comment section. So stay tuned and thank you. Next video will be coming soon.